Hello, good morning. I am Suman Sharma from Government Polytechnic College, Khunni Majra. Today we will discuss properties, multiplication and inverse of matrices. First of all, definition of matrices. What is a matrices? A set of mn numbers. Numbers may be real or complex. Means any numbers, not necessarily all distinct arranged in a rectangular array having m rows and n columns is called a matrix of the type m cross n. Means if there is m rows and n columns, then matrix is of the type m cross n. For example, 2 0 1 1 3 4. Here 2 rows and 3 columns. Then we can write 2 cross 3. It has the numbers 2 0 1 1 3 4 are called the entries or elements of a matrix. Now n m cross n is usually written as means there is m rows a1 1 a1 2 first row a1 3 a1 4 and a1 n. And now this is second row, we can write a21 a22 a23 a24 a2n. And third row we can write a31 a32 a33 a34 and a3n. This is our nth column. And similarly we can write ith row ai1 ai2 ai3 ai4 and we can write here this is jth row ith row and jth column in between, and we can write AIN. This is our nth column and this is ith row. Now last, similarly we can write another rows and columns, and this is mth row, AM1, AM2, because this is our mth row, AM3 and AM4, and in between we can write AMJ, and this is AMN. So, thus this is M cross N matrix. A may be written as A equal to A I J M cross N. These are our entries. Now, after this, multiplication of matrices. Multiplication of matrices. Let A and B are two matrices then their product AB is only comfortable is number of rows, number of columns in A are equal to the number of rows in B, means number of columns in A is equal to number of rows in B, means the product AB is possible when number of columns in A is equal to number of rows in B. Means if AIA equal to AIJ M cross N and B equal to BIJ N cross P, then C means product equal to CIJ M cross P is called the product of A and B, means number of columns in A is equal to number of rows in B, then the product is M cross P. Now some examples based on multiplication. A equal to 1, minus 2, 3, -4 2 5, b equal to 2 4 2 3 5 1. Now this is 2 rows and 3 columns, and here is 3 rows and 2 columns. Number of columns equal to number of rows, then the product is our possible. Now how to multiply? First of all, we take first row and first column, 1 multiply by 2 plus, this is -2, -2 is multiply by 4 plus 3 is multiply by 2. Now this is our first element. Now next we will take first row and now second column. First 1 multiply by 3, again plus, -2 is our number, this is multiply by 5 and 3 is multiply by 1. Now for second row we will take second row and first column, -4 is multiply by 2, this 2 plus 2 is multiply by 4 plus 5 multiply by 2. Now again second row and second column, -4 multiply by 3, 2 multiply by 5 plus 5 multiply by 1. Then what we will get? 2 -8 plus 6, here -8 plus 8 plus 10, here 3 minus 10 and this is plus 3. Now here is -12 plus 10 plus 5. What will become? 8 minus 8, this is 0, 8 minus 8 0 and this is 10, and here is 6 minus 10 minus 4, and here is 15 minus 12 3. So this is our product. If the in the product AB, A is called prefactor and B is called the post factor, and one thing is very important, that is AB is not always equal to BA, means product of A and B is not always equal to BA. Sometimes it may be equal to, but not always. Now, for this AB is not equal to BA, for this we will take an example. Let us A is equal to 0, 1, 2, 1, 2, 3, 2, 3, 4, and B is equal to 1, 0, 1, 0, 2, 2, 2, 2, 0. Find the question is find the product AB and BA. Now first of all we multiply AB. We discuss product. First of all we take first row and first column. 0 multiply by 1, 1 multiply by 0, 2 multiply by 1. Now again first row second column, 0 multiply by 0, 1 multiply by 2 and 2 multiply by 2. Now again row is our first and column is now third. 0 multiply by 2, 1 multiply by 2 and 2 multiply by 0. Now for second row 1 multiply by 1 plus 2 multiply by 0 plus 3 multiply by 1 means second row first column. Now second row second column, 1 multiply by 0, 2 multiply by 2 and 3 multiply by 2. Now again second row column will be third, 1 multiply by 2, 2 multiply by 2, 3 multiply by 0. Now for third row, this is our third row and here we will take first column, 2 multiply by 1, 3 multiply by 0, 4 multiply by 1, and third row second column, 2 multiply by 0, 3 multiply by 2 and 4 multiply by 2. 2 multiply by 0, 3 multiply by 2 and 4 multiply by 2. Now third row and third column, 2 multiply by 2, 3 multiply by 2 and 4 multiply by 0. Then what will we get? 0, 0 and this is our 2. We can write here. Now 0, 2 and 4. Now 0, 2 and 0. Now 1 plus 0 plus 3. Here 0, 4, 6. Now 2, 4 and 0. Here 2, 0, 4, 0, 6, 8, 4, 6 and 0. Then what we get 2, 6, 2, 4, 10, 6, 6, 14 and 10. This is our product AB. Now what will be BA? For BA we will take next page. We can write here B first. B is our 1 0 1, and this is 0 2 2 2 2 0, and for A 0 1 2 1 2 3 2 3 4. Now multiply. First row, first column, 1 multiply by 0, 0 multiply by 1, and 2 multiply by 2. Now first row, second column, 1 multiply by 1, 0 multiply by 2, 2 multiply by 3, and again 1 multiply by 2, 0 multiply by 3, and 2 multiply by 4. Now second row, 0 multiply by 0, 2 multiply by 1, and 2 multiply by 2. Now second row, second column, 0 multiply by 1, 2 multiply by 2, and 2 multiply by 3. Now second row, third column, 0 multiply by 2, 2 multiply by 3, and 2 multiply by 4. Now third row, first column, 1 multiply by 0, 2 multiply by 1, 0 multiply by 2. Third row, second column, 1 multiply by 1, 2 multiply by 2, 0 multiply by 3. And third column, third row and third column, 1 multiply by 2, 2 multiply by 3, and 0 multiply by 4. Then what will we get? Here is 0 0 and 4, 1 0, and this is 6. Here 2 0 and 8. Here 0 2 and 4. Here 0 4 and 6. Here is 0 6 and 8. This is 0 2 and 0. This is 1 4 and 0. This is 2 6 and 0. Then product will be equal to 4 6 2 7 10 and 5 10 14 and 8. And the product of AB we get 2 4 6 6 10 14 and 2 6 10. So we can conclude that BA is not equal to AB. Elements of BA is 4 6 2 and elements of AB is 2 4 6, and second column here 7 10 5, here 6 10 14, and in third column in BA is 10 14 8, and here is 2 6 and 10. So the product of AB is not equal to BA. not always, but sometimes it can be equal. Now, after multiplication, we will discuss adjoint of a matrix. Adjoint of a matrix. First of all, definition: the transpose. What is transpose? If we change column in rows and rows in column, then we can say transpose of a matrix. Transpose of the square matrix formed by cofactor of the elements of the given square matrix taken in the form of a determinant is called the joint of the given matrix. Symbolically, it can be written as adjoint A of the given matrix A. If A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3, then adjoint A is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3, where A1, B1, C1 are cofactors of A1, B1, C1 respectively in determinant A. Means A1, B1, cofactor of A1 is this A1 and cofactor of B1 is this B1 and cofactor of C1 is C1. Now question: find the adjoint of a matrix. Find the adjoint of the matrix A. Elements of matrix A is 1, 0, -4, minus 2, 2, 5, 4, 1, 3. Now we can write in determinant form 1, 0, minus 4, minus 2, 2, 5, 4, 1, 3, because cofactors we